In this video, we want to see how many 4-digit numbers have at least a 7. The first case is when the first digit is a 7. So note, because we're looking at 4-digit numbers, the first digit cannot be a 0, because otherwise it wouldn't be a 4-digit number. So there's only one choice for the first digit, and that's the 7. Now the rest of these, I don't really care what they are. So they could be any of the 10 digits. Now in order to calculate the probability, the first number, we have to choose from 9 numbers. Okay. So we're going to choose from 1 through 9 for the first digit. And so that's 9 choices. Now for the other ones, we can choose from 0 to 9. And so that's going to be 10 digits. So that'll be 10 over 10. Multiplying and simplifying, we get 1 over 9. Now the second case, we want to see how many have the second digit, that is a 7, but also the first digit cannot be a 0 nor 7. Because if the first digit is a 7, then we're going to overlap with this case here. Okay. So we want to have unique cases. Okay, so if the first one is not a 0 or 7, that means there's going to be 8 choices. That could be the first digit. The second digit is a 7, so that's only one choice. And then the third and the fourth digit could be anything. So that's going to be 10 choices. Now putting this together, a probability, with the first digit there's going to be 8 choices out of 9 because the numbers that you could choose from are from 1 to 9. And then the other digits are from 0 to 9. So because we can't pick 7, we'll have to choose from 1 through 6 and then 8 and 9. So that's going to be 8 total digits out of 9. And the second one is only one digit to choose, so that's going to be 1 out of 10. And then the third and the fourth could be anything, so that's 10 over 10. Now you multiply and simplify and get 4 over 45. Now the third case is when the third digit is a 7. So recall the first digit cannot be a 0 and 7. So there's going to be 8 choices for that. The second digit also cannot be a 7 because that would overlap with some of the cases in the second case. So there's going to be 9 choices for the second. The third digit has to be a 7, so there's only one choice for that. And then the last digit could be anything. So there's 10 choices for that. So now we multiply the probability. So we have the first one is 8 choices out of 9. The second one is 9 over 10, since you don't want that to be a 7. Third digit has to be a 7, so that's 1 out of 10. So the 1 being 7. And then the last one could be anything, which is 10 over 10. Now you multiply and simplify and get 2 over 25. Lastly, we want the fourth digit to be a 7. So the first digit again can't be 0 and 7. Also, the second and third cannot have a 7 because that would overlap with the previous cases. So for the second and third case, there's going to be 9 choices. And the last one has to be a 7, so there's only one choice for that. Now we calculate the probabilities. So the first one we've already went over is 8 over 9. The second one, there's 10 numbers altogether, but the only restriction is not being a 7. So we throw out the 7, there's 9 that we can choose from. Same thing with the third digit. Now the last digit has to be a 7, so that's going to be one number we want out of the 10. Multiply and simplify, we get 9 over 125. Now let's put it all together. These were the probabilities for each of the cases. So add those together, we get 44 over 125. And recall that there's going to be 9,000 four-digit numbers because for the first digit, there's choices 1 through 9, and the last 3 could be anything from 0 to 9. So 1 through 9, there's 9 digits. That's what we put in the first one. And the other ones, we don't really care what they are, so there's 10 possibilities for each of those 3. So you multiply these and get 9,000 four-digit numbers. Okay, now we just take the probability that it contains a 7, which is 44 over 125, multiplied by the total 4-digit numbers, and get that there are 3,168 four-digit numbers that contain at least a 7. And that is our answer.